All right, guys, so let me have your attention here. Welcome back. Hopefully everyone, I know the mouse will freak out like that. All right, let's have a seat. Jordan Schnabel, sit down. Thanks. So here is what we are doing today. We have a full jam-packed day. First thing, I want to go, hey guys, thank you very much. I want to go over this. I'm not going to go over every single tiny detail of this. I'm going to go over the broad general ideas. As you can see, I am recording it right now, so I will throw this up on my website. So if you need to go back and see what you got wrong, if you need to kind of review this, it'll be up on my website by this afternoon. Okay? I am recording. Say hi, Cody.
Hi, Mr. Chung.
All right. So, first things first here. Thank you. I'm giving you data points. The whole point of this was understanding a few things. How to graph distance versus times, and also how to graph velocity versus time. Let's do a very quick recap here. Last class we took some notes. And with those notes, I wanted you to come out with two broad ideas as far as what the slope of the lines of those two different graphs tell you. So if we have a distance, or what's the name for distance versus time graph? Nope. Well, it'll show velocity. What can we replace distance? Maybe I'm not asking the question clear enough. Good. So it's either called a distance versus time or a position versus time graph. Now, based on what's on the y and x axes, what does the slope of a distance or position versus time graph tell us? So if we have distance over here, which is measured in meters, we have time down here, which is measured in seconds. What is measured in meters per second? Speed or velocity, not acceleration. All right? So you have to understand that the slope of a position versus time graph will give you speed or velocity. All right? I'm not going to plot these points exactly, but your trend line should look something like that. Okay? Now, ultimately, what it wanted you to do was to figure out average speeds or average velocities at different times in this travel. Okay? So if we are looking at what is the average speed after 2 seconds? Well, we could have done this a few ways. Based on that trend line that kind of looked like that, you could have simply done rise over run. How many did you go up? How many did you go over to get to 2 seconds? That could give it to you, rise over run. Or you could use your data points here, which I would find easier. So we know that your rise on your graph is what? Is it your time or is it your distance? Distance. So your rise is going to be distance. Your run is going to be time. So look, there it is. You have your distance divided by your time is equal to your speed. There it is. That's the formula that we talked about last class. Okay? So after 2 seconds, well, the distance, total distance traveled was, we started at 0. After 2 seconds, we're at 75. So we do 75 divided by the time it took to travel 75 meters, 2. So 75 divided by 2? 32.5 or is it 37.5? 37.5 meters per second. That's 0 to 2 seconds. Anybody have any questions on that one? Okay, let's look at who can tell me what the next question is?
30.
Hey guys, there's a lot of extra chatting going on here. Bear with me. Give me 10 more minutes to go over this here. Next question asked after 3 seconds. Okay? So our rise is distance. After 3 seconds, we're at 90. The time obviously is 3, right there. 90 divided by 3 is what? There it is, 30 meters per second. Questions on that? Good. What's the next question asking us? After 5 seconds. So therefore, which you could have done, which is fine. Hey guys, I'm not going to ask again to be quiet as I'm going over this. So 125 after 5 seconds. Distance traveled was 125. Time was 5 seconds. What does that come out to be? 25. So if you notice, guys, as we are going down, we are getting slower and slower and slower. So therefore, your math calculations match the trend of this position versus time graph. Okay? And I think there were some questions in there saying, what was the average speed between 2 and 4 seconds? Well, if it's between 2 and 4 seconds, we can easily figure that out as well. Just we could do rise over run, or between 2 and 4. So we know that we started at 75, we go to 110. So what is the distance that we travel if we start at 75 and go to 110? 35. Time that it takes to do that is 2 to 4 seconds, which is 2. And what does that come out to be? 17.5 meters per second. Good. So again, it's all rise over run. It's all distance divided by time. So any questions with this first graph? If there are no questions, I'm going to move on then. Next bit, I'm giving you numbers. All I wanted you to do was figure out the acceleration. All right? So before we get rolling here, someone needs to tell me what the formula for acceleration is.
Final velocity minus initial velocity.
Good. Good. So there it is. Vf minus Vi divided by t. Final velocity minus initial velocity divided by time. And look what I give you here. I give you initial, final, and time. So therefore, 24 minus 0 is what? Divided by 3. 8 meters per second squared. Please understand what the unit of measurement means. I went over it last class. I'm going to go over it again. Meters per second squared, guys, is also written as meters per second per second. So for every second the object is traveling, it's increasing its speed by 8 meters per second. Okay? If we look at number 2, 35 minus 0 is 35, divided by 5? 7 meters per second squared. Good. Next one. Final velocity is 60, initial is 20. 60 minus 20 is? Divided by 10? 4. You got it. 4 meters per second squared. 150 minus 50 is 100. 100 divided by 5? 20 meters per second squared. And then the last one, 1200 minus 25 divided by 3600 comes out to be what? 0.33? All right, so any questions on those? All right, let's move on then. I'm going to do one of these. I'm going to do number 6, and then I'm going to go down to, I think, 8 or 9, which is a little bit more difficult one. They're all very much the same. So if we're looking at number 6, a car accelerates from a standstill to 60 meters per second in 10 seconds. What is the acceleration? Please follow my lead when solving word problems. I know a lot of people struggle with word problems, but if you can, first of all, write down what's given to you, all right, and then using what's given to you, look at your formula banks that you will always get on quizzes or tests. If you have no idea what the formula is, see what matches with it. So what I mean by that is this. So a car accelerates from a standstill to 60 meters per second squared. How do we show numerically what a standstill is? 0. So therefore, we have Vi is equal to 0. And it travels up to 60 meters per second. So what's that? Good. That's Vf is 60. We have a time of 10. We want to know what is the acceleration. So now, again, I think all of you would realize that we have to use the acceleration formula here. But if you didn't, look at your word or your formula bank, figure out which ones these fit into. So therefore, we're going to have acceleration equals VF minus VI over T. VF is 60. VI is 0. Time is 10. So therefore, what is the acceleration of this car? 6 meters per second squared. Good. There it is. Very straightforward. So any questions on 6? I'm going to go down to 8 here just because it's a little bit different. Just by the fact that, there's a typo, meters per second squared. A train is accelerating at a rate of 2 meters per second squared. Its final velocity is 20. What is the velocity after 30 seconds? So in this case, we know that A is 2. It's telling us its initial velocity is 20. We know that the time is 30. And we want to know what is its velocity after 30 seconds. So we are trying to find out what VF is. I think you're wrong. Spoiler alert. Really? Yeah. Spoiler alert. Miss Smarty Pants was wrong. All right. All right. Here we go. Now we have our formula. Hey guys, we have our formula. We have our givens. So we know A is 2. We don't know VF, so I'm going to put an X there. We know that VI is 20. We know that time is 30. Now, this comes down to, order of operations. So please excuse my dear Aunt Sally. Yeah, I know, man. That thing again. Are there any parentheses? Are there any exponents? Are there any, please excuse M, multiplication? No. Is there division? Yes. Got to take care of the division first. So we have to get rid of the 30. Since originally it's being divided by 30, we have to multiply by 30 on both sides. If we multiply this side, hey guys, listen up please. If we multiply this side by 30, those cancel. If we multiply this side by 30, we end up getting 60 is equal to x minus 20. Then we have to continue on order of operations. There's no addition, but there's subtraction. So how do we get rid of the minus 20? Add it. So if we add it to this side, that cancels out. We add it to this side, we get x is equal to 80. And I implore you to check your work. Put 80 back up here. 80 minus 20 is 60. 60 divided by 30 is 2. So 80 is correct.
I got the answer right, but I did the work in a different way.
I know the next one, though. Spoil that one.
I think it's sent to me at the time.
2 plus 20. Yeah.
Will that work every time, or is that just...
No, it works. It'll work. You just cross multiply without showing the steps. You're good. Yes. What's that? And did you get the answer? I'm sure you did some. I'm sure you did some sort of derivation of that. Yeah, that's what a lot of kids did. That's fine. That's fine. All right, questions on 8. Yep, I'll go over 9 too. Here we go. A runner achieves a velocity. Hey guys, stop. If you have a comment, raise your hand. If you have a question, raise your hand. A runner achieves a velocity of 11.1 meters per second 9 seconds after he begins. What is his acceleration? What distance did he cover? So if we're looking for acceleration, so we don't know acceleration. Final velocity is what? 11.1. 11.1. Initial velocity? 0. I don't tell you that, but if a runner is running a race, ready? Here you know what their initial velocity is at the start line. There it is, not moving. All right? And the time is 9 seconds. So therefore, 11.1 divided by 9 comes out to be about 1.23 meters per second squared. Yes. Yeah, Julia, go ahead.
So, how many decimal points do you want to?
It doesn't matter. It doesn't matter. if it really does concern me, I'll say round to the nearest hundredth or thousandth or tenth or whatever. So, and finally, what distance did he cover? So understand what this means here, 1.23 meters per second squared. So for every second that the runner is running, he increases his speed by 1.23 meters per second. So technically, the first second he's covering 1.23 meters. The second distance, he's covering how much? Yeah, so you're pretty much doubling. It's going to be exponential. So ultimately, we can do 1.23 times 9. It comes out to be about 11.1. All right.
Yeah. How did I get that right?
You multiplied it by 9, probably. All right, next one here, guys. This is a speed versus time graph. So therefore, what does the slope of a speed or velocity versus time graph show you? Speed is measured in speed is in meters per second. Time is in what? Seconds. So therefore, the slope of this line is showing meters per second per second. So what is the slope of this line of this graph showing you? Acceleration. Good. So this will show you the acceleration of the object. Again, I haven't even looked at this acceleration, so it's going up the same. It should technically look like that. You can answer all of these questions, guys, by rise over run. That's it. Rise over run again. Can I answer any specific questions on this graph or on these questions? Graphing is easy. You guys have been graphing forever. Now, the part that you haven't been doing forever is analyzing the graph and understanding what the graph is showing you. Okay? So can I answer any specific questions on this? If there's no questions, I'm going to move forward and look at the last one here. So this is a distance versus time graph. There was one question that I was concerned with that people might have a difficult time on. I'm giving you distance and time. So I'm giving you enough information to find out what the speed of the object is based on the slope. The question that I think people may have had a difficult time with is I have you calculate the average speed at 20 and 30 meters at 20 and 30 seconds. So I'm having you calculate the speed. That's nothing more than distance over time. So distance over time for 2 seconds, or for 20 seconds, distance 12, time is 20. So therefore, can someone tell me what the average speed at 20 seconds is going to be? 0.6. It's a speed, so it's meters per second. Very good. And then after 30 seconds, I think it's 20 divided by 30. 0.67 meters per second. Now, we know that a position versus time graph does not give us acceleration. However, we know what the formula for acceleration is. We know that it's A equals VF minus VI over T. Do we know the final velocity? Yeah, we do, right here. We just calculated it at 30 seconds, so it's 0.67. So it's going to be 0.67 minus initial velocity, if we're talking about 20 to 30 seconds, is 0.6. The time between those two is what? Nope, time. Yeah, 20 and 30 seconds is 10. So it's going to be 0.07 divided by 10. It comes out to be what? There it is. That is the acceleration. So you can end up calculating acceleration from a distance versus time graph. You have to do some math. The slope doesn't tell you it. All right, but you have to do math. So any questions with that? 3, 4, 5, and 6 are the same thing. You calculate your average speed at 40. You calculate your speed at 60. This is going to be your VF. This is going to be your VI. And then you're going to divide it by 20 seconds this time. Okay? Any questions? If no questions, I'm going to